You are a target. You are targeted with your username, with your password, with your email, and even with your web server and your financial transaction. You are always targeted, no matter what. I'm going to share with you some of the latest topics and trends about cybersecurity, especially code security. Code security is the practice of writing secure and reliable code that can withstand various types of attacks, such as SQL injection, XS scripting, and others. Writing secure code is very important to satisfy the requirements of the users and your customers, as well as comply with the regulations of the government and the standards. Hello, everyone. My name is Walid Nasri. I am the Deputy GM of Technical Affairs at Source Code LLC. I have over 15 years of experience in IT industry. I worked as cybersecurity analyst, system administrator, database administrator, and project manager. I need to say that cybersecurity is not only about protecting our data and systems from hackers and cyber criminals, but it's also about ensuring the privacy, integrity, and availability of our data. Here's an overview of what I'm going to talk about. First, I will talk about how a minor exploit can affect larger companies or large companies, how a very little bug can affect large companies. I will talk about some statistics about security and how security begins with the developer and the user. Code security best practices, what to do, what not to do. Then we will have some time to how to self-penetrate your own application or your own app. Before we start, I just need to stress, I cannot stress this point enough. No matter what you do, you will get attacked. No matter how much you follow security guidelines, every standard out there, you will get attacked. Let's talk in case of physical security, maybe you build a house, you put advanced locks, advanced locking mechanism. A hacker or a bad criminal or a thief can smash down the wall and be inside the house. So you will get attacked no matter what you do. Maybe you are working on a smaller project, your role is very small, you have just one API for balance checking. You say, I'm not gonna bother secure this API or encrypt it because it's just for balance checking. Any minor exploit can be exploited and can bring down your whole system. Please feel free to ask any questions if you want. I have some cookies here, beautiful Pokemon cookies I just bought here from Thailand. They are awesome. If you ask me any question, I will give you a cookie, okay? For a cookie for every question. So please go ahead, ask me, interrupt me anytime you want, no problem. This is how startups usually ignore security. At first, we say, let's just get the business running. We do not have time for security right now. Let's just put our app online out there for users to check. Before we launch, we remind ourselves that we need to care about security, but not right now because we do not have time or budget to care about security. After we have been online for 10 days, okay, maybe now it's good time about security, but okay, we will check it maybe later on. Then we get attacked, our web server is down, and we act surprised. Well, how did we get attacked? Well, because we didn't care about security, that's how. And I'm not kidding, this is real. Many startups face the same issue and got attacked like this. Here are examples of security incidents. Mandiant, the security firm Google bought for $5.4 billion, got their Twitter or X account hacked. They are a security firm and they got their Twitter account hacked. The impersonator promoted their own cryptocurrency wallets to sell their cryptocurrency wallet in the name of Mandiant. Another vulnerability was BMW subdomains. It has a sub-redirect vulnerability. The URL, if you look at the below URL, it seems like it's legitimate BMW URL. So users of BMW website or even employees in BMW website will access this URL, will not know that it's a phishing URL, but it has a redirect at the end that for a malicious website. Another attack or another vulnerability was systems used daily like Windows. So a DLL hijacking technique in Windows was focused about last year maybe. So it allows remote code execution and remote backdoor for hackers. Also, hackers discovered a way to access Google accounts without a password and while bypassing two-step verification and multi-factor authentication. How they used it? Because they were able to obtain cookies of some users. So these cookies, using these cookies, they were able to access the accounts without a password and bypassing multi-factor authentication. There's a blockchain developer has his wallet emptied because of a job interview. He was conducting a job interview with some organization. They sent them a GitHub link to download an NPM package to do some tests for the job interview. This link that he downloaded contained a backdoor for his computer. They accessed his computer, his data, and emptied his wallet. He was looking for a job interview and he got attacked. A data breach at a healthcare firm affected 4.5 million patients. The leaked data contained addresses, names, addresses, date of birth, social security numbers, and even billing and claim information. You can imagine how the hackers will use this data, how will sell it online. With ransomware, it's increasing recently. So any let's say, beginner attacker that not very advanced can now buy the source code for Zeppelin ransomware for $500 on any hacking forum. So, and they use this as RAS, or ransomware as a service. So they provide services for people to buy this ransomware and to attack others using this ransomware. Far from hardware vulnerabilities, from software vulnerabilities, let's move to hardware vulnerabilities. The United States water utilities were hacked after they left their passwords of the default password for their water pumps for 4 ones, 1111. This is default password. They left it all over the United States. Their water pumps were hacked and they disrupted the whole system. So, Cybersecurity and Infrastructure Security Agency, CISA, urged manufacturers to stop using default password on their devices because this default password will be a problem if not changed. What did they do is that to include time-limited or setup-only passwords that can be deactivated once the device is set up and completed. Another hardware issue is with the iPhone, when an undocumented hardware feature from Apple was able to bypass hardware security platforms and protections. This threat, if chained together, will cause a zero-click exploit that can elevate privileges and allow remote code execution. This bug was with iOS 16.2. It has 4 CVEs as follows. If you didn't read them, I can share the presentation later, so I'm just gonna go quicker. Again, if you have any question, just ask me right away. If I'm going too quick, just let me know. Another security advisory from WordPress, it's a backdoor plugin. Users received emails feeling very, very similar to WordPress, like it's a legitimate email from WordPress. It says that you have to update the plugin right away. So if the user clicked on the download button, it will be redirected to a fake WordPress website and download the button. This is the fake landing page. It looks legitimate from WordPress. If you press download, the backdoor will be installed on his device and will allow access for their environment to attackers. According to helpnetsecurity.com, 86% of cyber attacks are delivered over encrypted channels. So it's an attack, but over encrypted channels. What are some recommendations to help prevent encrypted attacks? Also, according to helpnetsecurity.com, you can use proxy-based architecture to bypass and decrypt traffic. You can use SSL inspection to inspect all traffic. You can leverage an AI-driven sandbox to contain the attack. Use zero-trust architecture, and use user app segmentation to enforce least privileged access. This is very important, the least privileged access, even for authenticated users. How usually attackers target APIs? They use DDoS attacks, man-in-the-middle attacks, or maybe mismanagement of tokens or API tokens, and non-encrypted credentials. Let's talk now about security for developer and for user. For yourself and for your users if you are the developer. You have to always, always, always protect your personal accounts using multi-factor authentication, using recovery email, using password. You cannot believe how many times I face people working in the industry, working in coding, in developing, maybe in network administrator, and they do not protect their own account, their own Facebook or their own Gmail. They forget their recovery email, they forget their password, they have everything. If you are a developer and you forget your email, how are you going to protect your user? So it begins with you, then you transfer this protection to your users. When you build an app or a website, always build it with security in mind. Keep security from design, from the first day, keep it. We will get to this point later on. According to statistics from ISSA.org, 71% of organizations are facing cybersecurity skill shortage. So cybersecurity skill shortage is a great issue. We are having this skill shortage affected many companies, about 71% of them. And it's companies reported that they take month-long to fill cybersecurity positions than it did 2 years ago. Some companies reported that it takes up to 7 weeks to fill a critical cybersecurity role. That's how the skill shortage is affecting the companies, affecting everything. To focus this or to fight this, the United States government deployed cyber-focused FBI agents for their embassies globally. So they understood that there are skill shortage. They need to raise awareness for every embassy globally. So they deployed cyber-focused FBI agents. According to statistics from IBM Security Report, Cost of Data Breach Report, the average total cost of a single breach is $4.45 million, which increased 2.3% from last year. The average total cost of breaches, if a breach happened between 50 to 60 million records, the average total cost is $332 million. And 82% of breaches that involve data stored in a public or private cloud. Only one-third of breaches were identified by organization internal security and tools. So if you have a security team, only a third of the attacks will be identified by your team. Maybe other types of attacks need external companies. 51% of organizations are planning, only 51% of organizations are planning to increase their security awareness after having data breach. Security AI and automation is saving costs, reducing costs, and reducing time to identify and contain breaches. In average, it took about 277 days to identify and contain a data breach. Now let's jump to security best practices. If you want you can always learn from people's mistakes. Read online articles, read magazines, read every article about security, because you know what people happened, what mistakes they do, so you can learn from them. Develop tools to detect and correct your problems. Have QA assurance. Plan to have everything compromised. If you are planning a code, you are writing a code, you are connecting with API, plan to have that remote server shut down. Plan to have your own environment shut down. Plan to have a remote recovery site or other backup tools in order to keep yourself online most of the time. Always use character escaping. Always use whitelist instead of blacklist. Blacklist when you deny something, whitelist when you allow only single characters to be used in your URL. Do not assume any character will be escaped just because the standard says so, or because your browser does it. You have to check it manually, okay? Use punning code for host names. Most people ignore this, but punning code, if you use it for host name, and percent encoding for the remainder of the URL. If you have a URL that has values to be delivered from database, check it again, check it carefully for dangerous characters. Keep all your systems up to date. Always keep your systems up to date. If you are using a web server, Apache, IIS, or any other web server, if you are using a framework like PHP or other libraries, keep them updated. But do not rush in installing these updates, because you have to read the patch notes, read the release notes, and compare what change does it have, how it will affect your other system if you have any other system connected together. If you are building an app that has billing as a backend, avoid checking balance locally. So one time, we were working in a gaming company, online gaming company, and this gaming company have a item shop inside the game. What we did was we have a billing system, so we connected our item shop to the billing system. As soon as the player or the user opens the item shop, it will check for balance and report it to the HTML5 in our page. What happened is when some users discovered that they can click buy multiple times, okay, but the only balance will be detected once. Because of our fault, we stored the balance locally. We did not check each time with the billing system. So what happened, the players can buy paid one time only and got multiple copies of the item. This cost us multi-$1,000 actually. So avoid doing this later on. If you are working with third parties or billing server, this makes sense for IT, just to make sure that you are opening on your firewall only designated IP addresses. This falls usually when people are working on test server, then going to the live server. If you are working on test server, you open everything because it's a test server, it's a test environment. I will secure it later on. But later on, you find yourself, you open to the public and you get attacked. Test your environment, not only do code testing, test your own environment. Have a test server identical to your live server. After you finish your code and publish it, testing for performance. Once we have a test server, about 100 users, concurrent connections. We're testing everything. We test all modules. Everything was fine, okay? When we went to live server, the server crashed because we had 500,000 concurrent connections. So we will not be able to test for performance, so that's why our server crashed. So we compromise the availability of our data. Always organize your comments. Always use comments and organization, because even you, later on, will forget what this code did. Once we had a programmer, she was very, very good programmer, but she did not comment at all. So even herself forgot what this code do when she wanted to fix a bug or did something. So always organize your comment and keep documentation of everything you do, because you're not working on this project forever. Someone will take your place. So make it human readable, make your documentation clear, so the one will get after you can read it and can benefit from it. Again, implement multiple modules. If you are using many modules in your code, in your application, implement multiple modules and span it across different files and modules, because sometimes you have a website with a password change function. The funny thing is, with this password change function, each time we deploy something on the website or maybe change something with CSS, the password change function will cease to work, will stop working. Why? We have no idea, but because we have everything in single module, so it keeps crashing every time. So always avoid putting all your modules in a single file. Avoid hard coding. Again, this hard coding, avoid hard coding the username, the password, the database IP addresses. Limit user privileges on the database as possible. We all do it. We all developers. Sometimes when we create an app, we use the database IP as localhost, username root, password root, and that's it. That's okay for our local test server. But when we go to a live server, we cannot use the same, of course. So what we do is we hard code everything, and we fall a victim if we went to a live server. If you have a connection between your web server and database server, keep the connection between database and web server on the private side. Do not open your database server to the internet, because it's very, very risky. Okay. Use machine learning when possible. Previous one? Okay. This is common sense. If you have login pages, if you have actually, this is a requirement by some payment companies. If you have a login page on your bank account, you should not offer to save the password in your browser. So the user data will not be breached or will not be at risk at all. Always use HTTPS, of course. Try code analyzers, they are really fun and helpful. There's some open source code called Find Bugs. It's really helpful to organize your code and give you where you have problems. Use machine learning SecOps, ML SecOps when possible. It's very effective, it saves time, it's available as open source. The benefits of machine learning is it offers advanced cyber threat detection. It has capability to detect attackers faster than human analysis. I'm just gonna be quicker right now because, okay. Now from sans.org, we have some securing web application. Again, a list of recommendation, error handling and logging. Display generic error messages. What do I mean by this? No handled exceptions, suppress framework generated errors, log all authenticated and validated activities. I will show you how. This page happened to me today, this morning. I was working on some website, and this error happened. Okay, I blocked out the domain name, so I will not disclose it. But this is a WordPress error with PHP and everything, and it says the error on line 34. This is huge in terms of security. This is a big deal. You cannot display this error to your end user, because if I'm an attacker, I will know that this server is running PHP. Of course, it's running Apache or something else. So it's running WordPress. I will go online. I will figure out what are current WordPress vulnerabilities. I hope that the administrator did not apply the patches or security patches, and I will attack this organization, all based on a single error displayed from the user. So these error messages should not be visible to users at any cost. Use HTTPS always, use strong password. Always have strong, iterative, and salted hash for your password. Of course, do not store passwords as clear text in your database, of course. For authentication, again, do not hard code credentials. Develop a strong password reset policy. I will share these later if you want, because the list is very big, okay? Input outlink, always use whitelist instead of blacklist. Validate uploaded files. If you have any upload files, it's not always enough to just limit the file extension. If it's .jpg, okay, let it upload it. If it's .exe, stop it. No, even if it's JPG, you have to validate this uploaded file to check if it's a malware or something else. Configuration operation, okay, session management. Okay, destroy that, always destroy the session after the user logged out. What happens sometimes is user logged in and the user logged out, but the session is not ended from the server side. This will keep the session open, and an attacker using the same, maybe the same IP address even on the same network, can access the session and can compromise user data. Access control, okay. That's quick how to self-penetrate your own app. I use Kali Linux. Kali Linux is a great tool. It's open source. It's very fun to use. You can use it on a hard drive, on a USB drive, or you can just deploy it on a virtual machine. But keep the using of Kali Linux is prohibited by law to use it against someone else. Use it only to test your own application or your own account. This is the interface of Kali Linux. You have information gathering, vulnerability analysis, web application analysis, database assessment. It's very fun to use. It's like wizard-like, and it's really helpful. Even if you are not a cybersecurity analyst, if you are a developer, you have to check it because it gives you an idea how the attackers work. The features, advanced tab testing, information gathering, vulnerability assessment, password attacks, it's all very helpful and very beautiful. At the end, no matter what you do, you will get attacked. Make peace with it and learn from it. This quote, I like it very much, as we have come to realize that the idea that security starts and ends with the purchase of repackaged firewall is simply misguided. That's what we thought security was 10, 15 years ago, but it's very wrong right now. Cybersecurity awareness and education and enhancing skills and sharing knowledge is the key for a secure future, okay? We have to raise awareness. We have to fight this cybersecurity skill shortage in order to protect our future. Thank you very much.